Alright, so here is 6.3, box and whisker plot. And we're going to also talk about percentile, is a little extra concept we're adding in there. About box and whisker plot first, okay, about box and whisker plot, we need to know the 5-number summary. There are 5 important numbers and the general shape of a box and whisker plot. So, the 5-number summary are, I want the minimum, the smallest value. We want quartile 1, which is actually the middle of the first half of the bottom half, or the 25 percentile. And then we want the median, which is the middle of the entire data set. And then we want quartile 3, which is the top, the half, the middle of the top half. And then we want the max. Okay, so I went over, we discussed about these 5 values in class. I explained what quartile 1 and quartile 3 means, the first quarter, the third quarter. If you think about a game, you have the middle, the halftime, but the first quarter is the middle of the bottom half, okay? And then the third quarter is the middle of the top half. So that's how you need to think about it. And then you have the smallest number and the highest number and the middle number. So those are the 5 important numbers. I like to put them all in the same order always, so we don't ever mistake how to find them. The general shape of a box and whisker is something we've never seen before. So we have a box, and then we have whisker, okay? There's little tiny whiskers on the side. So this middle part over here, the median, is not always in the middle. You could get any shape of a box and whisker. Usually this is the general shape of it, but you could get just a small box with a median right there, one tiny whisker, one long whisker. So it could be any transformation of this general shape over here. You could actually have a nice long box with a median and just one tiny whisker and no other whisker at all. Okay, so you could have any transformation of this general shape right here, box and whiskers. So don't be alarmed if you have if you don't have a whisker. All that means is that the quartile 1 and the minimum were exactly the same number. So it could happen. And then we're going to talk about percentile at the end of this video. So we always need our 5-number summary, because the 5-number summary is what constructs this box and whisker plot. Okay, each piece of this, each part of it that I am highlighting over here, it is one of those 5-number summaries. Okay, so let's go ahead and create one so we can understand it better. But before, I am going to create a box and whisker here, the general shape. I have a box and a whisker, another whisker, and I'm just going to put a line in the middle. Each of this represents a 5-number, one of the numbers of the 5-number summary. This tiny little one here represents the minimum. The bottom part of the box represents quartile 1. This slash in the middle represents the median. The median is not always in the middle of the box. Could be somewhere here in the box. This top part of the box is our quartile 3. And then this tiny little dot here we put at the end, it is our maximum. Sometimes people put just a slash like this. Sometimes some books put a little dot. Okay? So those are the 3 parts of the box, and the whisker is the minimum, the quartile 1, the median, the quartile 3, and the max. That's why we need the 5-number summary, so we can construct the box. Okay? The same way we need a frequency table so we can create the histogram, we need the 5-number summary so we can construct our box plot. Now, this doesn't mean anything if I don't have a number line in the middle, okay, below. I need a number line. And the number line tells me the values, okay? You can put all the values in the number line so we can guide our box and whisker plot. So that is roughly the general shape of a box and whisker plot. So let's go ahead and create one. Okay, we have this number 1 through 8 on your worksheet. Let me see if I have it here, right there. Okay, this whole 1 through 8 on your worksheet 3, box and whisker plot. Okay, I just grabbed the numbers and I wrote them here so I can help you understand a few little tricks. Whenever they give me a lot of numbers, First, we need to scan it and look for an outlier, okay? It is really hard to tell an outlier just visually without actually calculating, which is something we'll learn way later on in Math 3. But I can at least sort my data, okay? I see 80s, I see 70s, 90s, 60s, and 40s, and there you go. It helps you a lot if you put the 40s. Do I see any 50s? I see 60s, 70s, 80s, and 90s. So I am just doing a sorting. I haven't even started putting the data in order and looking for anything. I'm just sorting the numbers. An 88 is going to go here under the 80s. 76 goes here under the 70s. Another 77. 95 goes here under the 90s. A 69 under the 60s, and so forth. I am just sorting the data. I'm not doing anything. I'm not creating a histogram, anything yet. I'm just sorting it. 83 goes here. 88 goes here. A 99 goes here. 83, 75, 62, a 45 goes here, and then a 76, a 93, a 84, a 81, a 74, and a 68. All I did was grab them and put them in a sort out fashion. Now it's easy for me that I sorted them. It is easy for me to come over here and says, sort your data from smallest to largest. Because now I have a nice visual of everything I have here. So the smallest I have is a 45. Then let me go to the 60s, is a 62. Then a 68. Then a 69. So I'm done with the 40s and the 60s. You see how I did that. Now let's go to the 70s. Looks like a 72. Then a 74, okay, then 75, then 76 twice, 76 twice, and 77. You see why it helps a lot to create this sorting at first, especially when we're doing this by hand. So the 80s, 81, then 83 twice, so 81, then 83 twice, 81, 83, 83, any more 83s? Nope, 84 and 88 twice. So 84, 88, and 88. See how nice that was? Now let's take care of the 90s. Is a 95, nope, is a 93, 93, then a 95, then a 99. Look at that. We were able to sort them carefully. We sort them one time this way, because we put them in 60s, 70s, 80s, and 90s. Then it's easy for me to sort that without making any mistakes. It's very easy to make a mistake and miss a number, okay? So now that I have it in order, that was part 1, they said find the minimum, the quartile 1, the medium, the quartile 3, and the maximum. I like to put little stands, 1, 2, 3, 4, 5. This is for my minimum, which is 45. And then this one is for my maximum, which is 99. Now let's separate the data into two halves. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 8 on each side, 9 on each side, and there is our middle. So our middle is 77. And this is my bottom half, and this is my top half. Okay? Now, let's go to the bottom half and let's separate in the middle. 1, 2, 3, 1, 2, 3. 4, 4, we get 72 to be our middle. The middle of the bottom half is 72. That is our quartile 1. Let's find the middle of the top half. 1, 2, 3, 4. 1, 2, 3, 4, and we get 88 to be the middle of our top half. 88 is our quartile 3. So that is how you find your minimum, your maximum, the middle of the entire data, and then the middle of the bottom half and the middle of the top half. That's your 5-number summary. Find the IQR, the interquartile range. So that means it's quartile 3 minus quartile 1. I already have them right here, which is 88 minus 72. So that is 8 minus 7 is 1, and 8 minus 2 is 6, is 16. Create a box and whisker plot for the data above. The smallest number I have is a 45, the highest is a 99. So I'm going to go by fives, but I'm going to not start from 0, 5. I'm going to start at 30, okay? So here's 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So nice, and divided that nicely there. Okay, now let me switch it to a green pen. And let's create our box and whisker plot. I like to start from the middle. So the middle is 77. So here's 75. Roughly 77 is going to be right here. Okay, 77 is going to roughly be right there. Then I'm going to put the bottom of my box at 72. So if this is 70, 71, 72 should roughly be here. And then the top of my box is quartile 3, is 88. So here's 80, 85, 86, 87, 88, roughly right here. So now let me connect my box and close it, okay? So I told you the medium is not necessarily in the middle. There we go. Now I need to create my whiskers. My whiskers, I need to go to the 99. This is 90, 95, almost to 100. That is going to be my top whisker right here. And then I'm going to go drop all the way down to my bottom whisker, which is at 45, roughly right here. And there's my the bottom whisker, okay, the bottom part. So this is my minimum, 45. I can label them. This is my quartile 1, which is 72. This is my median, which is 77. This is my quartile 3, which is 88. And this is my maximum, which is 99. So no one should be confused at what each of these little pieces of the box represent. Let me zoom in. And there we go. Okay? Now, identify any outliers in a data set. This is visually. As you can see over here, let's go back to this piece of paper I had before. When I sorted them the first time, I got lots of 90s and 80s and 70s and 60s. But then we have this 45 way out here, only one, it skipped the 50. So it kind of like 60, 70, 80, 90, but we skipped the 50 and got this 45. I would consider this an outlier, okay? So identify any outliers, I would say the number 45. If I was to pick a number that is just not close to the others, would be 45. It says create a box and whisker plot of the data without the outlier. That means I have to take out the 45 and redo my 5-number summary. 1, 2, 3, 4, 5. I have to take out the outlier and I have to redo the counting. So let's re-separate the data, and the middle is going to be a little bit different. So help me out here. Let's see here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 on the bottom, separated right here, 77, and 9 on the top. So the bottom now is no longer 45. Now the bottom is a 62. The top is still a 99. We took out the 45. But now the middle is between 75 and 81. That's what the middle is going to be now. So I have to add 77 plus 81 and divide it by 2, so I can now find the median. 100, oh, did I do this right? Let me do it again. 77 plus 81 equals 158. When you divide it by 2, you get 79. So now this is 79 because I got 77 plus 81 and divided by 2. Because this is the middle of the data now. Let me do it in green. This is the bottom half now, and this is the top half now. Okay? Now let's find the bottom of the bottom half. So 1, 2, 3, 4, and we got 74 in the middle. So 74 is the middle. And now let's find the middle of the top half, the new top half without the 45. So that is 1, 2, 3, 4. I must have made a mistake. Oh no, it's 88. Okay? So we got 88. Let me count it again. I took the 45. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have 9, I definitely have a middle. 1, 2, 3, 4. And 1, 2, 3, 4 is 74. And here's 1, 2, 3, 4. It's 88. 1, 2, 3, 4 is 9. It's 88 as well. Okay. So everything is good. I have the 5-number summary without the outlier. I'm still going to go by 5s. So let's go ahead and do 30, 35, 40, 45, 50, 55, 60, 70, 80, 90, 100. Now let's do a box and whisker plot without the outlier. The middle is 79, really close to the 80. And then down to 74, that's 75 right here, so 74 a little bit below. And up to 88, this is 85, 88 roughly over here. Okay? So all of a sudden the median now is a little higher than it was here. Here was between 75 and 80. This one is still between 75 and 80, but is a little higher. Okay? And then the maximum still goes up to 99, so right here. But now the minimum only comes down to 62, so roughly over here. It's not going to be precise, but it's roughly right here by the 60. Okay? So look, we took out the outlier and everything shifted a little bit higher. Okay? Look at your minimum now is a 62 instead of a 45. Your quartile 1 instead of a 72 now is a 74. Your median was a 77, now is a 79. And then the top kind of stays the same. So compare the two box and whisker plot. How does the outlier affect the graph? So the outlier made the median lower. Okay, it made the median lower, and I guarantee you that it shifted the box. Because it shifted the box, it definitely changes. It also changes the mean. Okay, it changed the mean a little bit. If it affected the median, I'm pretty sure it affects the mean as well. Okay, if you take an outlier, it changes the values of things a little bit. Okay, what effect will the outlier have on the mean of the data? I just answer over here. It will definitely change the mean. It will increase the mean. The mean will increase, and I will tell you why. Because it affected the median. It also affected the median of the data. So now we have higher minimum. Okay, the minimum is higher. Here instead of 45, now 62. The median shifted a little bit. The quartile 1 shifted a little bit higher. So I think our mean will definitely increase as well. Test it. There's nothing better in mathematics than testing it. If you add all these numbers and divide it by how many are there, and then take out the 45 and do it again to see what you get. It is a wonderful investigation for you to find out. Okay? And this is all about box and whisker plot. Okay? So that is your whole first page. On the back page, they're asking you which way smaller numbers. But you're creating two. You're creating one box plot on the top and you're creating one on the bottom so you can compare the median. Is one the median higher than the other? So the mean will be different. It will be interesting to see. You got to investigate the median and the mean and how it works. Okay? The last thing I need to cover here is percentile. Let me see if I can find the paper I wrote for percentile here. Oh, it's right beneath it. Okay? Last thing I need to cover is about percentile rank. Now, percentile rank, according to the definition in the textbooks, are the values that are less than or equal to divided by the total number of items. So what you're looking for, the magic word here, is less than or equal to, okay? That's the magic word. So if I had something that is less than or equal to, I just have to divide it by the total number of items. Let's see if it makes sense here on the problem. The magic word is less than or equal to. I cannot enforce that enough, okay? It says, of 25 scores, that's my total number, okay? I have 25 scores in the Math 1 class. 15 of them, okay, 15 scores are less than or equal to 85. What is the percentile rank of 85? If I was to rank the score of 85, what percentile rank would be that score? So according to my calculations, P is for percentile, the percentile rank. It is the value that is less than or equal to. So 15 scores are less than or equal to. And you divide by the total number of items, which is 25. That is all work that you have to do, okay? So let me clear here, and you have 15 divided by 25. And that is equal to 0.6, okay? Ignore that phone. 0.6 times 100, and you get your 60%, okay? So 60 is your 60 percentile rank for the data value, for the percentile rank for 85. Myers. Oh, they hung up. Okay? So that is how you do a percentile. It's just the score that is less than or equal to divided by the total number of items, the total number of scores. Okay. Let's do one more, especially because we got interrupted by the phone. All right, next one says, of 35 judges' scores, so that's the total, all right? It's always nice for us to understand of 35 judge scores, that's my total. Awarded during a gymnastic event, 28 are more than 7.5, comma, okay? So 28 are more than 7.5. What is the percentile rank of a score of 7.5? Well, my percentile rank is always the less than, the value less than. They didn't give me that. They gave me 28 are more than 7.5. Well, if you think about it, if you have a total of 35 people and you subtract 28 that were more than, then that means you have 7 that were less than. So if 28 are more than 7.5, then that means that 7 of them are less than or equal to 7.5, the score of 7.5. If 28 or more than 7 got the score of 7.5, then 7 of them got less than or 7.5. And that is the magic number I need, okay? So that would be 7 divided by 7 people that got less than 7.5 or 7.5, divided by the total scores that were given there. So when you divide 7 divided by 35, you get 0.2. You get 0.2. All you have to do is times it 100, multiply it by 100, and you get 20 percentile. Okay, so that is the 20 percentile rank. Okay? And that is it for percentile. The magic is less than or equal to. Okay? And that concludes our video for 6.3. Good luck. Come and ask me for help. It is always a pleasure to help.